Hello everyone. Welcome to the Building Sustainable Business Through Life Cycle Assessment webinar. I'm moving over to the next slide. So we have some housekeeping rules. So all of you are muted at this moment, except myself and the other speaker, Niranjan. So the meeting is recorded and it will be shared with you after the session. At the end of the webinar, we would send out a survey. Please do fill them and send it back to us. So in case you have any questions or comments, please write to us at compliance@apengineering.com and we will reach out to you at the earliest. So I have with myself Niranjan Ramasubramanian, who's a dedicated sustainability expert at APA. And I'm Ranjini Vatharajan, who is managing the compliance division. So before we go ahead with the session, I would like to speak on who we are. So we have over 23 years of experience as a company. We have our offices in the United States, EU and APAC regions as well. We are ISO 9001, 27001 certified. So we also have TISAC certification and we have more than 350 customers. And actually we have 4 main divisions. We work with compliance, engineering, sourcing and technology. We offer both a turnkey solutions, services and also software as a service. I'm moving over. So what sets ABA apart is our customer-centric solution. We are constantly focused on, giving customers innovative solutions from concept to revenue realization. We are serving both original equipment manufacturers and also Tier 1 related customers. And we have more than 22 years of compliance-related experience. And we have more than 400 experts with us. And we also have a lot of solutions that is available to help customers ease their compliance process. We have process automation tools, data management tools, and also reporting tools available with us. Moving over to the next slide. So here are some of our compliance coverages. So we work on TISCA, REACH, CROSS, IMDS, and all sustainability related compliances like ESG. We are also diverging into CBAM right now. And also we give importance to EU Factories Directive. We also work on packaging regulations and NDR and SDS and PFAs and PFOs also. And we also work on supply chain due diligence related compliances like. So here's the agenda for the day. So I would give an introduction to LCA, followed by a short session on what is carbon footprinting. Then we have one real life example, and then finally we will conclude the session. So I'm going into the introduction to the LCA. Before I move into this introductory phase, I would like to start a poll. Please answer the survey question. Okay, that's nice. Still polling is in progress. Okay, thank you for voting. I'm going to close the poll. I hope all of you can see my screen. And so I'm beginning with the introduction to LCA. So as we all know, life cycle assessment or life cycle analysis There's a systematic, comprehensive method for evaluating the environmental impacts. It can be associated with a process or else a product or else even a service. And they're going to cover the scope throughout the entire life cycle. So LCA is in short a very tool or a methodology to quantify a sustainability. That is why we say LCA is connected to sustainability. I'm moving over to the next slide. So there are various purposes of why we perform life cycle assessment. As we said earlier, it is one definitive way to quantify your sustainability initiatives. And we can see that I'm going to list down some purposes of LCA. One is environmental impact assessment. So it is very useful in assessing all the impacts on your environment, like resource depletion. So what emissions go to the air, water, and how much energy you're consuming, and how much waste is being generated by an organization. Like it can be associated with a particular product or as a process. Then we also use LCA as a comparison of alternatives. So suppose our organization is trying to move into sustainability, then you want to find out, suppose we have a product, we have a battery, and we want to find out if my current product design is really good, and it does not create a lot of impact on the environment. So we can use LCA to compare different product designs. So I can design a battery, and then I can design another battery A and B, and then compare the results in order to understand which product design will actually least impact the environment. Moving over. So, and LC is also used in decision making, because as I spoke earlier, it is going to assess your environmental impact and hence your performance. So LCA will support decision making. Then your processes, it can be used to optimize your processes. More sustainable processes can come in place, and then also help you with material selection, and also internal policy development. And LCA can also be used for a targeted improvement. When we say that, because when we say the life cycle assessment, it can be throughout a product or a service in an entire organization. So performing an LCA life cycle will allow you to see, where your process is efficient, where your process is inefficient, and it can target that specific areas, and we can allow improvements on the specific area. For example, let me say that for example, I spoke of battery as an example. So let me take product A battery and product B as battery, and I'm involving. Like for the production of the battery, I'm using a lot of lithium, and I'm supposedly sourcing lithium from a supplier, and I find that out, that sourcing from that specific supplier is costing me, is one, it's loss of it is driving a lot of cost, and secondly, it is also not effectively being used. It is creating some issues with by consuming a lot of energy from this particular supplier. So I can see where my issues are when we perform LCA, and then we can target an improvement for that specific phase, so which will be in the manufacturing process of your battery. So changing of lithium to another supplier or a better supplier, or changing lithium itself, going for another alternate, may actually help you consume lesser energy and thereby reduce your cost. So I am moving over to the next slide. So then you also have LCA. The purpose of LCA is to drive more transparency with your consumers, investors, stakeholders, because you know how your process or product is is having an environmental impact, and you will be able to better communicate with your stakeholders. For example, you can say, okay, so we are having this production facility where you are running an LCA, and supposedly you're using solar solar power to drive all the to be more energy efficient. You can tell your stakeholders, see, like we have reduced the consumption of electricity overall. Earlier you were using 100% of grid electricity, now we have switched over to 50% of solar, which means that you have really come down, and you can communicate with your stakeholders, who will in turn invest better in your organization. So that's for communication transparency. And you also have a policy related development by using LCA. So I'm moving over, and you also LCA. One of the purposes of LCA is to really help people come to a position where they have a life cycle mindset of thinking. So you are going to encourage a broader perspective perspective on sustainability, because you're not going to focus on just a single product, but it is going to be a specific area where your product is manufactured. You're going to associate all the related processes with it, so covering an entire life cycle of that specific product or process will also help you in moving gearing up towards your sustainability practices. And the most important purpose of LCA is like it's more data driven. As I already spoke, it's like a tool for, or a methodology for calculating your, I mean, like your understanding where you are on sustainability. It's a tool to measure sustainability. It will quantify your data, because LCA is heavily relying on the inputs that you provide. So for example, whatever goes in and whatever comes out, all those inputs and outputs would have to be documented. And that sort of a data driven approach will help you like understand or quantify your sustainability initiatives, or how you want to go in the future. So, and like in the overview, we can see the standards for LCA. We have two major standards. I mean, there are a lot of standards. I'm just going to speak a few on that. One is the ISO 14014, 14040, and 14044. And with respect to ISO 14040, it is going to tell you the principles and the framework of a life cycle assessment. So there are these are the standards in place. So what it is going to provide you is with a principle and guiding framework for LCA, and it will, what is covered in this specific standard is that it's going to cover the goal and scope definition, and what is your inventory analysis, what is the impact, and how you can interpret. So it will give you an idea or guidance on how to define your system boundaries, and how to perform your inventory analysis, and then how to find out your impact and categorize your impact, and how to actually what conclusion we come into. So that is what is the standard used for. And then you also have your ISO 14044, and this is going to give you specific requirements and guidelines. So how you're going to conduct an LCA, and it is going to give you a lot of procedures for how you want to go about collecting your data. So having your system boundaries, so your impact assessment, and also reporting and interpretation of the assessment that you have conducted. And 14067. So the first two standards are the widely used standards. We also have ISO 14067 from 2018, which is going to give you requirements and guidelines for quantification of your data. So this is specifically more aligned to the carbon footprint of your product. It is going to provide you the principles, the requirements. How are you going to quantify your product? I mean, guidelines for quantifying and reporting your carbon footprint for your product. And this other standard is ISO 14025. So here it is about your labels and declarations. So it is like type 3 environmental declarations, and it will give you the principles and procedures. So this is mostly used for environmental product declaration. And then it will tell you, what are the standard principles and procedures that is to be followed out here. So when we say type 3 related environmental declarations, which means that type 3 means it's a quantified environmental data using predetermined parameters and additional information will be supplied wherever it is required. So you have type 1, type 2, and EPD is a type 3 environmental declaration, which is mostly used in product carbon footprinting. So I am moving over to the next slide. And the widely used protocol is our GHG protocol. It's been standard for most of the organizations. So it is going to allow you to understand and provide guidelines for measuring and reporting the greenhouse gases that is associated with the product's life cycle. So we use GHG protocol when your organization or as an individual you want to focus on the greenhouse gas emissions alone. If you do not want to, because LCA covers the environmental impact, it's not only about the air emissions. You also have emissions that go to land, water, eutrophication, and there are a lot of impact categories that is available in ACA. GHG protocol focuses mostly on the greenhouse gases related emissions. So that is when you go for the standard. Moving over to the next slide. And now we are going to see how to approach LCA. So when we say approaching is like what are the methods, like how we can perform an LCA. So life cycle assessment is basically a cradle to grave analysis, which means like you're going to find out how the environmental impacts are right from your procurement of raw materials from a supplier to how it comes to your organizational factory. If you have a factory or a facility, and what is the manufacturing process there, and how it is being sent out. So, and once it is sent out and to the consumer. So this is basically a cradle to grave analysis. However, if the organization is more interested in making it more circular, and you can go the whole way around and also include the waste, reuse, and recycle part. So in order to be inclusive, or as you want to go the whole way around, typically it's a cradle to grave. That is from your procurement of your raw materials to when your product leaves the facility to the consumer. So until distribution is the general approach to LCA. So that is why you conduct your LCA. In case you want to go circular, you can also include the reuse and recycling of all the waste materials that is being collected after the usage phase. So this is the major approaches that we have in LCA. And so whatever was spoken, we are just showing you a diagram of the same. So here you can see that you have your raw materials extraction, and then you are processing the material, then product distribution. So until product usage, you will cover the LCA cradle to you will cover the LCA cradle to grave. Product usage and product end of life will attribute to the to the cradle to grave concept or the methodology, and your circular will also encompass the disposal of your product waste. So that is what is being shown in the general stages in the life cycle. So I'm moving over to the next slide. So there, once you have decided what is the methodology you want to approach LCA with, whether it is going to be from, it's going to be a cradle to grave, or else it's going to be a cradle to cradle, then you have 4 stages in LCA that must be followed in order for you to complete the assessment. So we have given the general stages here. There are 4 basic stages that we can see. One is the goal and the scope definition. The second one is like life cycle inventory analysis, then followed by life cycle impact assessment and interpretation. So we have shown this with double arrows because once you have defined your goal and scope definition, even then after interpretation, you are seeing that something else needs to be added in the scope. So you can interpret your results there and then basically move on to again redefining your goal and scope. So that is why we are showing this as double arrows on all ends. So this is a very iterative process. LCA does not tell you like if you start from the cradle, you have to just cradle and end in grave, which means like once you define the scope, you have to move to life cycle inventory, and then you have to perform an assessment and then finally interpret. So that is not the case with the life cycle assessment. So you can reiterate each and every process when you find out there are there are certain improvements that you want to make. So each and every stage is iterative in LCA. So I'm moving over to the next slide. We'll just explain a couple of minutes on each and every phase in LCA. So first you see your goal and your scope definition. So the major purpose of the goal and scope definition is to finally identify what is the system boundary. As we say, LCA can be very, very comprehensive because it is the entire life cycle of your product or a process. It can be very comprehensive. You may not, you may want to, avoid certain system boundaries and include certain system boundaries for your assessment. There might be a particular, suppose you have battery production. There are two types of battery that is being, manufactured in your organization. You want to first carry out LCA with one of the products. So you will identify the product that you want to start the assessment with, and you will have the system boundary defined for that. So that is why the goal and scope definition is very important. So you have identified your system boundary. This is the process that you want to assess, and you also have to, like for example, I have given an example here. So I can say, okay, this is the product A. This is where I want to do my assessment. I want to find out how I can reduce the footprint of my battery. And I also want to know if there is any way I can improve the product design and thus contribute to the, a better product sustainability overall. So you have to identify your system boundary first. So, and you also have to identify your functional unit. So how are you going to measure your input and output is defined in the first stage. And then you also have your the second phase is obviously the inventory analysis. So in order to effectively manage and analyze resource consumption, emission, so it is essential that we quantify all the inputs and output for every stage of your product life cycle. Excuse me. So what we are saying is that when an environmental input, it is going to use raw material or energy. So what will your output be? So when you're going to use raw material, you're going to have and energy. Obviously, you will also have waste. You will also have emission. So your input will also correspond to a specific output. So you have to collect all the inputs and outputs that is involved in the scope of the system boundary. So what are you trying to assess? So once that is defined, so what is a unit of assessment? So what is your functional unit? How are you going to measure what you are required to assess? And the second thing is like you have to identify what are the inputs that are going into the assessment in that specific system boundary. So if you can see from the raw material to the production facility, we have transportation, and the production facility, there are processes going on. So for example, if you have identified this as a system boundary, so your raw material is input. So and for this input, so what goes in, and if you're once you use your raw material, what are the emissions that are coming out? So you have to have a inventory of what goes in and what comes out. So I'm moving over to the next slide. So based on the example of battery, I'm sorry. And based on the example of batteries that we were discussing, an example for the LCI based on the goal and scope that we just discussed is the, like identifying your raw materials. That is from this. What are you procuring? I'm procuring lithium, cobalt, and nickel. And so what I'm going to use during the manufacturing process, am I going to use some sort of, I mean, like, what do I use for, heating purposes? Is there any heating involved? I mean, and then I may use electricity during the manufacturing process. So that is also an input. And the emissions that come out of it, the waste that come out of it, all those are outputs. So that is an example. And then you also have your life cycle impact assessment. So this is one of very important stage when we come to. So once you have identified your system boundaries, and then you have moved over to assessing what your inputs and outputs are going to be, you have to perform an assessment. So how is this going to impact the environment is the next phase. So I have to identify the impact categories, though not listed here. There are standard impact categories for LCA. It can be acidification, it can be ozone depletion potential, it can be eutrophication, and all these are some of the important categories. And ionizing radiation, ecotoxicity. So how your outputs are going to impact the environment will be considered in this case. So are they going to be toxic for environment, human toxicity? So based on the example that we took, your battery is going to produce emissions. So how is it related to the impact category? It will be a global warming potential called as GWP. Because it is related to emissions, it is definitely going to affect the climate. And so all those will be categorized into GWP. So now you have a battery, and there are certain effluents that is being discharged. And so that is, and you're going to, without any, I'm just telling this as an example, and without any treatment of the effluents, you're just going to release the same back into the water. Then it will cause acidification of water. So understanding how your outputs, I mean, like, they are impacting, or input outputs are impacting the environment, will have to be categorized under a broad scope of impact categories that is defined in the LCIA. And for example, so I have given this, like, so for example, you are producing for a production of a battery during manufacturing process. So it is emitting about 60,000 carbon equivalent, which means, like, I have used nearly 150,000 kilowatts of electricity during the manufacturing process. Into its the electricity emission factor will actually give you the emissions that are coming out during the production of a specific factory battery. So this will be included under the global warming potential impact category. So moving over to the next slide. So the final phase is your interpretation, application, and reporting. During this phase, what happens is that, like, whatever you have analyzed so far, you would come to a conclusion of the results. So we are going to examine what has happened during the assessment, and we are going to interpret the entire meaning of the assessment that has happened. So what is the conclusion here is that we are going to extract valuable insights from the study. This is going to be used for decision making, and also for further improvement, and also to enhance your sustainability related actions. So based on the above example that we see for production of a battery, and how much carbon equivalent, that is how much of emissions is going out into the environment, we classify that under a global warming potential. So our emissions from the organization is actually destroying the environment in the climate. So when we say that, like, so what do I infer from that? So our interpretation can be like, I want to reduce the carbon footprint of the battery. I want to reduce the carbon footprint. So how can I reduce the carbon footprint? One way is by not using electricity from grid, but I would be using renewable sources of energy, which will bring down my electricity related emissions out from the, it will remove all my electricity related emissions. So the interpretation is actually allowing you to see, okay, where is your the worst impact that you have, and what we can do about that specific impact is where we do this interpretation. So there can be good outcomes also. Please understand all these examples that we are giving is like is not meant to be negative, but there can be positive outcomes of your interpretation, and there can also be negative outcomes. But finally, it is all going to move towards a very sustainable related environment. So I'm moving over to the next slide, and we have come on to the second part of the agenda, which is on product carbon footprint. So right now what we have seen is an overview of LCA. Of course, with LCA, there are a lot of items to be spoken about, because there are various different types of LCA are also available. Because of the lack of time, we have just restricted to a generic overview of what is life cycle assessment. I hope everybody has understood what life cycle assessment means and you have a high level picture of what happens in the life cycle assessment. And right now we are transitioning to product carbon footprinting. In product carbon footprinting, what we will look into what is actually product carbon footprinting. So when you have your entire life cycle assessment, and the product carbon footprint is nothing but it is actually a subset of your entire life cycle assessment. An organization may do an LCA from cradle to grave for their entire industry. So, which means it will account for all the impact and impact categories, and all the environmental impacts are considered in that sort of an assessment. As we saw in the previous example, so organization can impact the environment in the air quality. It can also cause acidification of water, and I mean, because it is impacting air quality, it is probably causing ozone depletion. And there are certain industrial processes which may be harmful for humans. I mean, the release of just toxic water right into a water system can actually be toxic for humans if we consume. So all these are being assessed under a general life cycle assessment. So your impact categories are huger and larger. There are about 15 impact categories for LCA, and we saw few of them. When it comes to product carbon footprint, we are going to relate the scope only to the emissions that come from a specific product. So as we saw in the previous cases, we were just talking about battery, but I may be concerned, I may be producing battery in a manufacturing unit. I may be producing, aluminum doors also in a manufacturing unit, and I may be producing other types of goods also in my unit. But there may be a lot of processes involved, because your raw material which comes in, your process is going to be different for each and every one of these products. But I can choose to just limit the assessment only to a specific product, whereas LCA for an organization is a summation of all the environmental impacts that happen throughout the process. So that is what is shown in this diagram. We are saying that product carbon footprint is nothing but a subset of the entire life cycle assessment. So in product carbon footprint, all we are going to focus on is the emissions in a product's life cycle. So that is going to be expressed as carbon dioxide equivalence. Yeah, so when we say a product carbon footprint, it will include the entire product life cycle. That is from the raw material extraction to manufacturing, distribution, use, and also the disposal of its specific product. So your product, finally, you would know that for producing this battery, this much of emissions has occurred. So that is our entire goal. So we will not be worried about all the other processes in the organization, but what is the emissions, or else what is the carbon footprint, or else embodied carbon emission of this specific product. Here in this case, we have been talking about battery, so let's stick to battery. So why do we need RPCF, product carbon footprint? It is mostly because we want to have the understanding and how to manage the environmental impact of a specific product. And it is also going to give us opportunities to reduce the amount of carbon emissions. So there are a lot of, for example, we work a lot closely with the automotive sector. And in automotive sector, you know that the manufacturing facilities, when they produce a lot of auto components, can be one of the huge sources of releasing a lot of carbon emissions, that is greenhouse gases in the environment. And for industries like this, and if they are selling a lot of products to their customers, it is always best to go with product carbon footprint, because they will know where they have to, I mean, where the, in producing what product are the emissions highest, and out of, through the product carbon footprint, how would I be able to reduce my emissions. So product carbon footprint will be very helpful in those cases. I am moving over to the next slide. So here are some reasons why PCF is important. See, the reasons for doing an LCA assessment and PCF are more or less the same. So I have just given 3 pointers, which is going to say, why PCF is important, because all the purposes of LCA are actually applicable. Most of them are applicable to your product carbon footprint also. So one is consumer preference. So there are a lot of consumers these days, they want to buy product which is more sustainable, which does not harm the environment, which does not release so much of emissions. So one is due to customers' preference. Then you also have a very competitive advantage, and also huge market. We would say, suppose organization is manufacturing, lithium batteries, and the emissions are like 50% lower. The organization is, for example, organization A and organization B is emitting 90%. So obviously, there will be many stakeholders or investors who are willing to invest in organization A because of, the emissions that is reduced, and they see a great value in that product. So it will set any organization apart. And it also is very necessary for most of the regulatory requirements. And we have CBAM regulatory requirement, which is, it, we wouldn't say it is like a complete product carbon footprint, because like most of the emissions in the indirect emissions are not included. But in any case, PCF is very necessary in order to finding out the carbon footprinting of a specific product, and hence in turn comply with regulations like CBAM. CBAM is nothing but I would just want to make sure. I'm not sure if there is anybody who's not aware of CBAM or they're aware of CBAM. So carbon border adjustment mechanisms, which has been, in effect since like late October 2023, and anybody who's importing into EU will be required to, give their carbon, embodied carbon emissions of their specific product. So that is why, doing a product carbon footprint is becoming very important these days. And so, as I said, there are growing demands, and this is just a statistic to support what we are saying. So there was Carbon Trust released an international new research paper where they said that more than 67% of their customers, they are willing to support products which actually, they have reduced carbon emissions. So this is one of the statistics that we are just giving out. And then, just as an LCA, your product carbon footprint also must be reported in order for you to comply with many regulations globally. And one of the standards that is provided to us is like ISO 14067. It's called an all-rounder because it's a very generic product carbon footprint guideline, which can be used across industrial sectors. So what does it provide? It provides guidelines and principles for quantifying and reporting a product carbon footprint. And this covers the whole product life cycle. That is like covers the full product life cycle. That is like the product manufacturing until the product manufacturing process In case if you want, there is a difference between using ISO 14067 and the GHG protocol, because your carbon footprint of products, or is the all-rounder standard, is not going to include some of the scope 3 related emissions. So if you want to have the carbon footprinting of your product right till your value chain, I think you have to go with GHG protocol. So that is one way to report. These are the common standards that's being used. So here is a sample carbon emissions report, which was publicly published by CMP. And you can see this is this is like an emissions. What is the source of the emission? How much units? What are the units? And and the units have converted into kilowatt hour. And what is the carbon dioxide equivalent? And they have also provided how much emissions is taking place in ton per carbon dioxide equivalent also. So they have categorized all these into different scopes. This is a sample carbon emissions report. We don't own this. And this is divided by the scopes. So when you say scopes, it means your scope 1, scope 2, scope 3. Your scope 1 is all the direct emissions that happens in your organization, or else your manufacturing facility, right on your site. And then when we say scope 2, it's all your indirect emissions. So you're purchasing natural gas, you're purchasing heating, you're purchasing electricity, and then you're using them. So all these emissions become indirect. And then you have your scope 3. These are all the emissions which you do not directly own, but it is mostly from your supply chain. So scope 3 is really intense and huge. This is a sample emissions report. Please understand, this is not a specific carbon product footprint report. So this is just given to help you understand what is actually being reported. And in case of product carbon footprint, you would not have to classify your emissions based on the activity that is happening based on your scope. It is going to be without the scope, because your product is going to give you the aggregation of all the scope 1, scope 2, scope 3 related emissions if we use a GHG protocol. In case of using the other ISO standard, it will not include the scope 3, the full extent of the scope 3 emissions. So we are just showing this as an example. And thank you so much. I would like to run another poll. Please vote for the poll that is being run now. Thank you. I'm just going to wait for a few more minutes. Okay, thank you for voting. I'm just going to close the poll and continue. Okay, this is a sample. This has been looked into. It's owned by CMP. So if you go and search for emissions report by CMP, you will also be able to see an entire report published. And so I'm just going to speak on product carbon footprint related reports. So as I spoke to you previously, so your carbon product reports are not going to be broken down into scope 1, scope 2, scope 3 emissions. You will just say, okay, this is my product, say a battery. This is emitting this much of emissions. And when we say that is the emissions for embedded in that specific product, it is going to be inclusive of your scope 1, scope 2, and also scope 3. And there are And I would like to tell you about the life cycle assessment databases and why it is important and why are we speaking this during the reporting of your product carbon footprinting is because getting your or getting our organization's primary data is simple, because you will know what amount of heating is going on. If you have your company owns a fleet, and then they will be able to understand how much fuel consumption has gone in, and so what are the emissions of that way, and they can also uh, identify the distance that the transportation has, the vehicle has gone in. I mean, all these are primary data which can be actually measured by the organization itself. Anything related to electricity, things related to purchasing of heating, cooling, and if there are going to be any water treatments within the organization, they're going to have a water treatment facility. So anything like your acidification, all these things can be monitored by the organization itself. But there are scope 3 related emissions which can be very difficult and sometimes to get the data from your suppliers. In those cases, we generally suggest that people will use the life cycle assessment databases, because they cover a wide range of industries, and they also provide the environmental impacts of products and processes across various sectors. And these are some of the databases which you can use for preparing your report. So one is EcoInvent, and one is Gabi, then ILCD, USLCI, and then you also have your PCR databases. The reason we are giving this information is because you have, irrespective of performing an assessment, all of us have to report the emissions based on the ISO standards. And you may not have certain supplier related data with you, or as emissions rate with you, or as you may be missing some emission factors, all of which you will be able to take from these publicly available LCA databases. And I'm moving over to the next slide. So not only reporting, when it comes to product carbon footprinting reports, that is what we saw. There is also another mandatory requirement which is coming up in place for a product carbon footprint. It is called as environmental product declarations. It's also known as EPD, and it is like a very standard document which will quantify the environmental impact of your product. For example, it's a label. What if you suppose you're manufacturing a battery, and then in this EPD format, if you stick a label, then people who purchase your batteries can understand the impact of your battery on the environment. So this is also being mandated across many places, and EPD, it will report a specific set of environment results, and these results can be obtained only when your organization is performing an entire life cycle assessment. So if you're going to declare, some of the information of your product, like a label, based on the EPD format that is being given, even in order for you to provide all this information, your organization naturally has to go through the life cycle assessment as a whole. Only then you will be able to provide the inputs that is being asked in this EPD. So I'm going to show what is actually required in the next slide. So some of the information that can be required in a EPD is like product description. So what is your boundary? And you also have to provide your LCA data, like your carbon footprint, your global warming potential, your acidification potential, eutrophication potential, resource depletion, any other relevant information, relevant LCA data that you have. Then you also have to mention on your methodology, and if there are assumptions that you have done during the process of your assessment for this specific product, then you would also have to mention that. Then what is the data quality, and when you do your scope and system boundaries itself, you will arrive at your functional unit. So how you're going to measure your impact. So that is your functional unit. And then you should make sure that whatever reporting is being done through this EPD is also compliant with the ISO standards. And this also requires a third party verification. And this is an example of an EPD. This is actually owned by Nora. You can also search it online, and then you'll be able to see the EPD report that they have given. So all they'll do is like they will release this information to the people who are purchasing their product. If it's going to be a battery, they better they'll also stick it as a label as a part of the battery. And so this provides a lot of transparency to the purchaser actually. So you can see some of the declaration number, then when it's being issued, then who's the owner, what is the product they are declaring it for, then what is the scope of the specific product. And you can see also that they have provided, the product description at the bottom. And what standard is this specific EPD compliant with, and whether it is belonging to a product. Have you really externally reviewed the product, and all sorts of information will go on this specific EPD, and this is going to be used as a labeling for many products by Nora. So we are coming to live case study. This is also publicly available. And the reason for coffee roasting UK case study was because I think all of us enjoy coffee, and we thought like it's going to be interesting, seeing how a coffee roasting, office was able to, arrive at their carbon emissions. So this coffee roasting company is located in Oxford area, and they wanted to understand, how much, what is the impact of their, them cultivating coffee in tropical regions, and then from, procuring it from that place, tropical regions into UK, and how they are roasting it with natural gas, and then they are also going to package it, and then they are going to distribute it to their customers. So this is sort of a light-hearted example that we took this time. So, and you also, as we said before, there is something called the primary data, which your organization will be able to provide. Here in this case is coffee roasting case, which can provide the primary data. There are also secondary data that is not available with them, and that is taken from secondary sources. So here, these are some of the assumptions. I mean, not assumptions exactly. This is a case study, and in the case study, we can see like what is a natural gas, that is being required to roast, green beans, like 1 ton of green beans into roasted medium beans. So how much, natural gas are you going to spend? So what is the energy that is coming out of it? So you can see that it's given as 1680 kilowatt per hour. So, and then once it is roasted, you also have to pack the coffee beans, for which you're going to use aluminum foil bags, and to, for package, they will be using. All these are important because your assessment is going to cover even your packaging and how you are going to use wastes. So you can see that, for packaging 1 kg of roasted beans, it's going to be like 31 grams of aluminum foil bag get used. And then for 3 kgs of roasted beans, so what is aluminum foil bag to package, that is also being given. And so when you are trying to pack them, there'll obviously be some wastages during the packaging operations, which we accounted to like 2% based on the case study. And then also once you have your you have your coffee bean prior to roasting those green coffee beans, and then post roasting. So post roasting there may be a weight loss, so we are accounting that to 20% of waste loss. So to obtain 1 ton of roasted beans, you need actually 1.25 tons of green coffee beans actually. And there are also assumptions that has to be made in order to fill the gaps. So this is the average distance. These are the transportation information that is required. So you are actually shipping it from your tropical regions, as we said. and into the Dillsbury Dock, for example, into the Oxford area. So which is like 5,000 kilometer by sea and 500 kilometer by road. And then, when you're transporting it, obviously you will need baggage, and that baggage, we are assuming like one 1 kg bag weighs like in 31 grams, and based on the above data, so 3 kg bags is going to weigh 52 grams on average. And so in order to for you to pack 1 ton of coffee, it's going to weigh like 48 kgs. Then we are going to also assume that on average, 100, like for the coffee delivery is going to be a minimum of 120 kilometers. So this are some of the data that we have from the coffee roasting shop in UK, and there are emission factors that are obtained from secondary sources, like based on what we discussed, because we would not have all the information. So here's how they have arrived at the emission factor sources for coffee production. So these are the secondary data descriptions. So you have your direct measurements, and your emission factor from DEFRA from 2012. So they have taken this data from your UK greenhouse gas inventory. So these are some of the databases from which this coffee roasting place has taken some data. So you also have, if you're going to transport it, like in a rigid lorry, what will be the emissions during your transportation? So you also can see that. Then for what will happen if you're doing a bulk carrier, what is a in ton per kilometer? All this is being taken from the DEFRA 2012. It's like from Department of Transport. So these are what we called as secondary data, which we discussed previously. So your emission factors or any information like for transport, you're transporting, they will give you, this for on an average for this much number of kilometers, this will be your emissions based on the type of vehicle that you're using. So these information can be derived from your publicly available secondary data sources, which we discussed prior. And we can also see, like, because we are using aluminum foil, then there is something called the wastage. And you have to transport the wastage to the specific landfill, and they have also given the data related to that. So, and to calculate the product carbon footprint of 1 ton of roasted beans, so which is been going to be packed in 1 kg and 3 kg bags, and they're going to be delivered across all the coffee shops. And so the primary activity data should be multiplied by secondary emission factors. So what we looked previously is all the primary data that is given by the coffee roasting company in UK, and what these emission factors that we see. For example, average UK rigid lorry tons per kilometer, ton kilometer, it would the emission factor would be 0.301. So which they have taken from Department of Transport. So all the emission factors are being used from publicly available databases, and this is what we are going to do. So we are going to have whatever is our primary data, and then we have to multiply that with the emissions factor from your secondary data based on the publicly available database. So what this company has not considered here is a use phase. I think we are running out of time. I'm going to finish this shortly. So, and your carbon footprint calculation would be your input activity. So, into your emission factor. That is your primary data into your emissions factor, which is from the specific database. So here you have you can see that I have given the description of the activity. So what is happening? So growing beans. What is the volume of beans that is being procured, or else like this beans alone. Then what is happening during roasting with the natural gas. So we saw from the primary data it is like 1680 kilowatt per hour. So this much amount of energy is being used to roast the beans. Then you also have packaging aluminum material. Then you also have packaging based aluminum. This is what happens, and we have given the volume and wherever applicable, and also the emission factors against the same. So for sea transport, so how much kilometer you're driving, so in tons. So you will have the data and the emission factor from the secondary database, and also in road transport, how much of kilometers being traveled and their respective emissions database. I mean emission factors. And then during distribution, we assume that the average distance is going to be 120. So we have that against the emission factor. So what we are doing is like, just directly multiplying, the activity into the emission factor wherever applicable. And the coffee roasting company in UK, they saw that, they are releasing like 6,370 kilogram of carbon equivalent per ton of roasting beans. So when they are roasting, a ton of beans, this much amount of emissions is being released into the atmosphere. So that is what they wanted to initially find out. They wanted to know how much, emissions is it taking for them to cover this entire process. Of course, this is not have the use phase in consideration. Use phase would be like when people use it, and then you also have uh, that phase is not being considered here, and neither waste phase is considered here. How you are going to what you're going to do with the waste that is coming out of this coffee, because you're going to powder the coffee, and all that coffee powder is going to be discarded. So they are not being taken into consideration. So finally, I'm just going to conclude the webinar. So LCA here is not going to determine which product or process is best. See, that is not, we can use LCA for comparison, but it is not going to tell, yeah, you have an organization which manufactures hundreds of products, and all their products are excellent. No, it does not give you that sort of a conclusion. And whatever information has been, what you get during the LCA study, it should be, it should be one of the component, and you have to have more comprehensive decision process, because you ultimately have to trade off between whatever assessment you're finding out, what is your interpretation, for example, what interpretation you have come up with, and what is the cost factor that is involved. Because for building a sustainable business with LCA, that is, we have quantified whatever we have received. For example, we saw that this coffee roasting company is emitting more than 6,800 ton carbon dioxide equivalent into the atmosphere. So and they want to decrease the emissions that is going into the environment. So what they can do, they can probably replace the natural gas they're using for roasting the coffee beans. But replacing natural gas also has a cost. So you have to decide, like, with the important stakeholders within the organization. So we are going to switch from natural gas to, I'm going to use some other means of roasting the beans. Through what will I roast the coffee beans, and what will be the ultimate emissions, and what cost is involved, is going to be literal trade-off. So LCA is definitely is really useful when you want to drive your organization towards sustainable development, but careful considerations have to be given when you're trying to like move into sustainable practices. You also have to be mindful of the costing factors that is involved here. So with this, I conclude the webinar. I thank all of you, and in case you have any questions, please write to us, or else you can, we will also send out a copy of the webinar, webinar, this entire session. Thank you for giving your time to us. Thank you for listening. Please reach out to us in case of any questions.